Have you ever noticed how the websites you use every day, from your social media feeds to complex dashboards, they feel less like static pages and more like actual full-blown applications? Well, that massive shift is at the very heart of modern web development. And today we're going to pull back the curtain on one of the key technologies that made it all happen, React. So here's our game plan for today. We'll start by looking at the why, the problems that old-school web development just couldn't solve. Then we'll dive straight into React's core ideas: components, props, and state. We'll see how those pieces come together to create that magic self-updating UI. And then we'll wrap up with a little peek into the future to see how things are getting even simpler. All right, first up, let's talk about the old way of doing things and why building interactive websites used to be, well, a real pain. Okay, so picture this. You want to build a modern interactive web page. You've got your HTML for the basic structure, but how do you make things happen? A button that shows or hides something, or a search box that actually filters a list. The answer was always JavaScript. And that's exactly where things got messy. With regular old JavaScript, you're directly messing with something called the DOM, the Document Object Model. Think of it as the live, tree-like structure of your web page. To change anything, you had to write code to manually find that exact piece of the page and tell it precisely what to do. For a simple site, maybe that's fine, but for a complex app, it was pure chaos, fragile, confusing, and an absolute nightmare to keep track of. So how did React solve this? Its first big idea was to get us thinking in terms of reusable components, like building blocks instead of one giant sculpture. And this idea was honestly brilliant. React said, stop thinking about giant monolithic pages. Instead, break everything down. Break it into small, self-contained, and reusable pieces called components. At its core, a component is just a JavaScript function that spits out a piece of your user interface. It could be as small as a button or a search bar, or as big as an entire section of your page. And the difference is just night and day. On the one hand, you've got the old way, a huge, messy block of HTML that's almost impossible to read. But with React, your page is just built from clean, descriptive components. You can literally look at the code and understand the structure of the page just by reading the component names. Take a look at this. You're looking at a pretty complex screen, right? Well, in the world of React, this whole thing is probably just one big app component. And inside that app component, you've got smaller components for the sidebar, the main feed, and so on. They're all nested together like building blocks, creating a clean, logical structure. So how do you actually write what these components look like? You use something called JSX. Think of it as a superpower for your JavaScript. It lets you write code that looks and feels like HTML, but right inside your JavaScript files. So you get all the easy-to-read structure of HTML, but with all the power of JavaScript right at your fingertips. It's the best of both worlds. Okay, next up, let's talk about passing data with something called props. This is how we make our new building blocks flexible and actually useful. So if our components are like little functions, how do we get information into them? Well, we use props, which is just short for properties. And honestly, the best way to think about them is exactly like arguments you'd pass to any other function. It's how a parent component can send data down to its children, making them dynamic and reusable. Now, this brings us to a golden rule in React, and it's super important. Props are immutable. That means they are read-only. A component can read its props, use that data, but it must never, ever try to change them. This rule makes sure that data flows in one predictable direction, from the top down, which makes your whole application way easier to understand and debug. But wait a minute. What happens when a component needs to remember something all on its own? This brings us to the idea of a component's memory, which we call state. Props are awesome for data coming down from a parent. But what about things that change because a user did something, like the text inside a search bar, or whether a drop-down menu is open or closed? For that, a component needs its own internal memory. And that's exactly what state is. It's data that is managed by the component itself. We give a component this memory by using a special tool called the useState hook. So let's just make this super clear. Props are like arguments to a function. They're passed in from a parent, and they are read-only. State is like a local variable inside that function. It's managed inside the component, and it can be changed. Getting this difference is probably the single most important step to really getting React. Okay, so we have components, we have props, we have state. Now for the big payoff, the absolute magic of the re-render, which is how React actually brings your UI to life. The official React docs say it perfectly. State acts like a snapshot. This is such a crucial idea. When you update state, you aren't just changing a variable. No, you're telling React, hey, throw away the old version of this component and re-render it from scratch. But this time, use this new snapshot of data. So let's trace the whole cycle. A user clicks a button. That click triggers a function that calls a state setter, something like setNumber1. That's a signal to React to schedule a re-render. Then React runs your components function all over again, but this time it uses that new state value. Finally, React looks at the new result, compares it to what's on the screen, and super efficiently updates only what changed. It handles all that messy DOM stuff for you. This whole process is a huge mental shift called declarative programming. You stop telling the computer how to do things step by step. Instead, you just declare what you want the UI to look like for any possible state. You describe the end result, and you let React worry about the most efficient way to get there. And finally, let's look ahead to the future with automated optimization and see how React is about to get even smarter so we don't have to be. For years, as our apps got bigger, making them perform well was kind of a manual chore. Developers had to carefully wrap pieces of their code in special hooks like useMemo and useCallback to stop React from doing extra work. It was tedious, it made the code harder to read, and honestly, it was really easy to mess up. But that's all changing. The new React compiler is an absolute game changer. It's a tool that automatically analyzes your code and just does all those optimizations for you. This means you can go back to writing simple, clean, easy-to-read code, and you get top-tier performance completely for free. No more mental gymnastics. So, let's boil it all down. You build your user interfaces out of reusable components. You pass data down to them with read-only props. You give them their own memory with state. Changing that state triggers a re-render with a new snapshot of data. And the most important thing to remember, React lets you focus on what you want to show, not how to show it. This move towards automating performance really gets you thinking, doesn't it? If our tools can now handle something as complex as performance tuning for us, what's next? What other messy, complicated parts of development can we automate away so that we, as developers, can just focus on what we love to do, building amazing things?